Good morning. These are your notes for how to build a protein, part 1, which is transcription. Okay, you're going to need your level of organization paper on the side. Today we are working at the molecular level, so you're going to highlight molecule. You're going to need to set up your Cornell notes over here on the sides. And the title is How to Build a Protein, Part 1, and this is transcription. Okay, so transcription uses existing DNA sections as template to make a copy. So basically it just means DNA is like a huge recipe book, and you don't need the whole recipe to make a protein, so you're just going to use a part of it, and you have to make a copy before you can actually make that protein. All right? So DNA is like a recipe book for how to make proteins. So a gene is a specific section of a DNA molecule that codes for one specific protein. DNA molecules are extremely long. You have 46 of them, so there's many of them, but your gene is just one small part of that whole DNA section. You have lots and lots of genes. All right, there are specific steps that happen to take a section of DNA and turn it into a usable protein. Okay, the first step, which is what we are going over today, is for a copy of the protein recipe to be made so it can be taken out of the nucleus. DNA is not allowed to leave the nucleus ever. It's on house arrest. It can't go anywhere. So if you're going to if you need the instructions from the DNA, you're going to have to take it out, and the way they take it out is by making a copy. Okay, mRNA, or messenger RNA, has the job of transcribing, which is making a copy, which is what transcription is. It's essentially just making a copy, the correct gene or section of DNA, and taking that copy out of the nucleus to find a ribosome so translation can begin. So translation is the second part. That's what we're going to be going over next time. The first step is just mRNA makes a copy, and it takes that copy out of the nucleus to find a ribosome. All right, so the mRNA copy is made by attaching mRNA bases, which are different from DNA bases. There's A, U, C, and G. Instead of a T, it's a U. That's how your body knows that it's RNA and not DNA. Okay, to an unzipped DNA portion to make a reverse copy of the protein recipe. Okay, it then detaches from the DNA and exits the nucleus through a nuclear pore into the cytoplasm to find a ribosome. And then once it finds a ribosome, that is when translation begins, and that's what we're going to be going over next time. Okay, so for this particular set of notes, you're going to be writing your own notes over here on the side. I am not giving them to you. If you don't write anything over here, that's minus a lot of points. So I recommend that you write them. All right, this is on page 60, and your foldable will be on page 59.